Hi everyone, I'm Kristiina Jokinen from AI Research Center at IST, National Institute of Advanced Industrial Science and Technology, Tokyo Waterfront. In this short paper, I will discuss challenges concerning the design and development of interactive, situated, context-aware robot technology. Let me start from the very early times. You may not readily think that the wheel is an intelligent system. In fact, it's a relatively new invention about 6,000 years ago after the nomad ancestors had learned to cultivate land. But its importance is that it allowed humans to change into a new type of life and society, carry things, move, generate hydropower, and navigate. When we look at the history of technological development and human society, we can locate various advanced inventions, from the wheelbarrows to cars, telephones, and automation, and to present-day technology concerning spaceships, computers, internet, robots, and so on. The reason why I bring these issues to you now concerns future views of society and its development. Surely, cloud technology and robots offered some new perspectives to extend and enhance our living, like the invention of a wheel 6,000 years ago. How technological development can shape the future society is a matter of a wide and sometimes wild discussion. In this talk, I focus on the skills and expectations of interactive, situated robot agents. The concept of Society 5.0 was introduced in Japan and is proposed as a future society that Japan should aspire to. This view of the future society assumes that economic advancements should be balanced, with the aim to find solutions to social problems by novel technology that integrates cyberspace and physical space. The goal is a human-centered society where the implementation of AI is safe and secure, and it supports high-quality life. As for human-robot interaction, the vision concerns symbiotic relations between humans and AI agents. Dialogue interactions allow human users to have access to knowledge available in the cloud. But how can the capabilities and characteristics of current robot agents shape the world, and also how should such agents shape the future societies and services? The first issue is related to the robot skills and interactive capabilities, which are determined by the current technology. The second one concerns expectations of the interactions and potential needs for social robot services and applications in various practical tasks and situations. These issues lead us towards the main discussion point of this talk. What is the particular role of the robot in a society, and how can we address boundaries between accepted practices and new challenges? The goal of my research has been to design and develop situated, context-aware robot agents. Situated interactions refer to behavior where action plans, that is, physical acts, and language understanding, that is, speech acts, are integrated. In practical applications, the ability to align the human speaker, show understanding, and give feedback, as well as infer the user's intentions and affective states, are important for the agent's communicative capability. The robot agent may also collaborate with humans on various assembly and caregiving tasks. The capability to move enables the robot to explore its environment and reach locations which are unknown and inaccessible, and then report back to the human. On the other hand, such agents need to be aware of their context. They need to categorize and disambiguate perception and recognize the presence and communicative intentions of other agents. The agent must also learn to understand changes in its environment so as to plan suitable actions related to the dynamic environment and its own goals. On the social interaction level, the agent needs to plan and time its action with respect to the actions of its partners and thus construct a common ground. An important aspect in the agent modeling, and in fact, one of the challenges in developing situated, context-aware robot agents in the first place, is the embodied and enactive nature of interaction. Following the cognitive theory of enactment, Experience of the world is a result of mutual interaction between the organism and its environment. Thus, human cognition is assumed to be based on enactment. Whether or not the robot agent has cognition is a philosophical question that we don't go into this talk, but we can say that the agent's capability of multimodal interaction enables it to act in the world and also participates in the dynamic creation of both the interaction and the environment together with the human. The interaction leads to a novel conceptualization of robot agents, boundary crossing robots. This concept has its basis in the robot's dual characteristics. On one hand, the robot is a tool with a huge processing capability. On the other hand, the robot is an agent with a dialogue capability. Such robot agents cross boundaries between the categories of tools and agents on the one hand, and between the categories of co-workers in human teams and mixed teams of humans and autonomous agents on the other hand. You can see our papers for more details. In an earlier study, we evaluated a robot system and asked users what are the most difficult aspects of the interaction. Users found it most difficult to guess what the robot can understand and do, unclear about the robot's capabilities. The conclusion is that the robot should have transparency in its tasks and interaction to make the human feel it's easy to interact, rather than trying to puzzle out what to do next and how to phrase things. Quantitative studies on robot users with long-term experiences are scarce, simply because there have not been many users of robots. But now, especially in Japan, various robots are available at reasonable prices for consumers, even on sale in department stores. In a recent study with my colleague Kentaro Watanabe, we studied the users' views of automated agents. The study concerned long-term users who have had an interactive agent at home for more than 6 months. The amount was 100 users in each class for now humanoid robot, Aibo robot dog, and an intelligent speaker. The research was presented in the Roman 2020 conference, so you may want to check our paper there. But I want to mention 2 aspects of the questionnaire concerning what the users think. This first figure shows the words used to describe each device. For humanoid robots, toy is the most used, followed by friend. For animal robots, pet is the first choice and toy is the second. For smart speakers, tool is selected most and toy is second. Humanoid robots and smart speakers are considered as toys or tools, but animal robots seem to be seen as agents, taking the roles of pets. The result gives support to the suggestion that in Japan, animal robots are crossing the boundary from toys to agents. This figure shows recommendation scores for each device. Humanoid robots have a significantly higher recommendation score than animal robots and smart speakers. It's interesting that robot owners recommend the robot as it's both useful and cute. By comparison, animal robots are regarded as cute but not useful, while smart speakers are useful but not cute. A key factor differentiating the 3 types of devices seems to be the word for cute in Japanese, kawaii, common word for anything attractive, and is often used about living things. The result that humanoid and animal robots have higher scores for cute than smart speakers can be explained, of course, by the physical resemblance by humanoid and animal robots to living things. However, if cute and enjoyable animal robots are already crossing the boundary to pets, as suggested earlier, their function must already be sufficient to nurture a relationship as a pet. By comparison, humanoid robots may require different factors to cross the boundary, such as acting as a friend or a family member, having better context-aware capabilities. This may be addressed in future research. I'd like to refer to our paper in Roman 2020 for further details. In this short talk, I discussed situated context-aware robot agents and the challenges in their development, focusing especially on how they seem to have social presence in the environment. Following the cognitive theory of enactment, experience of the world is a result of mutual interaction between the organism and its environment. In particular, human experience of the robot agents is developed in the environment which is co-created together with the robot agent. This leads to a new concept, boundary crossing robot, which facilitates interaction between different perspectives and crosses boundaries between tools and agents on the one hand and between human-only teams and mixed human-robot teams on the other hand. In the future society, boundary-crossing social robots are expected to join teams as helpful co-workers to support human well-being. It seems like animal robots are already crossing the boundary with perceived capacities, cute and useful as important factors. As for humanoid robots, they seem to require something more, obviously context-aware situated capacity. When sketching aspects of future society and its development with robots that change category from tool to an agent, it's important to notice that this change is triggered only if the robot is perceived as a meaningful partner with a genuine role in the team. This is all for my part. I'm happy to answer your questions and also discuss more about boundary crossing robots and wheelbarrows if you like. Thank you and see you around.